far we have discussed these three things. This generation system model, which is from the model 1, probabilistic reliability evaluation. Then we have introduced the background for frequency and duration method, which discussed mean time to failure, mean time to repair, right? And mean time between failures. Also, we discussed about hazard rate, okay? And we discussed that a typical reliability curve, which is something like this: initial failures, later failures, in between only service failures, right? Then we discussed continuous marker process, where we talked something about transition probability. Or the state transition matrix. Okay. So this is all about the background for frequency duration method. So today we are going to discuss how many models we are discussing in any method. The first approach was probabilistic approach. Okay. So this approach is frequency duration approach. So there what we did two things: generation model, load model. Okay. So just like that, we will have generation model and load model. So this is our topic of discussion. Okay. So first we will start with generation system model. So this is the problem in which we are going to solve it. So here, what is important is the failure rate, lambda, and the repair rate, right? Now this is something that we discussed. We use the following equations: frequency. Okay. So what we are going to exactly calculate for this problem? We are going to calculate state probability, which is, that means for what duration that state is available, and state frequency, right? Then we obtain the reduced model. What is the reduced model? We can have so many states, we convert it into a number of discrete, 5, 10, 15. So that's reduced. It's not very important. That's only useful for big systems like IEEE 24-bus system. Obtain the cumulative probability and cumulative frequency of each state. Okay, so cumulative values we will obtain. As we know, we generally use cumulative values. If each unit can exist in two states, so we will use a two-state model, either failed or operating. You can have three-state models also. One is failed, operating, partial operating. We have seen that. Then we had a four-state model where there was a result. But here we will take two-state model. If each unit can exist in two states, then there are 2 to the power n states. Okay? Where n is the number of units. So here we are taking 3 units. So what is the total number of states? What will be the total number of states? 8 states. So what will the state space model look like? That you have already done in the past. Check it. You have done the state space model for a 8-state system where you have made connections. Okay. So that diagram is very important for understanding how the state frequency and state probability are computed. Okay. So that diagram should be available to you for reference. Okay. That diagram is this. So those who have not done it, simply quickly just go draw it. Quickly draw it. 4 here, just make 4 here, 2 on the other side, 2 on the other side. Don't make the connections quick because we can do that while we solve the problem. Okay. So there are and also what we considered in the last class, that we are considering only single state transition. So if there are two states transition is there, for example down to up to down, two state transition, we are not considering those state transitions. So we are considering state transitions where there is only one, right? Right? You draw the blocks only, just draw the blocks only. Don't write anything else. Then you can fill up whoever has not started. Okay. The first thing that we are going to see in this case is rate of departure. Now those who have drawn the diagram just now, you can change this table and fill it out. In state 1, it is U. Just like this. You see, unit 1, 1 U, 2 U, 3 U. Like that. So here the states of all the states are there, all the generators. Cross check, those are already drawn. Cross check individual. Okay. So now we'll consider a single state. The state, so what you have drawn is a state transition diagram. The state transition diagram enumerates all the possible system states and also shows the transition mode from one state to another. And we are considering only single state transition. As an example, if given that the system is in state 2, given that the system is in state 2, in which unit 1 is down, the system can transition to state 1, 5 and 6 in the following ways. Okay, so 2 to 1 if unit 1 is repaired, 2 to 5 if unit 2 fails, 2 to 6 if unit 3 fails, right? Other two are remaining constant, same. DU. Okay, that is from 2 to 6. Other transitions we are not taking because in other transitions there are at least two state transitions. We are considering only single state transition. Okay. So in this case, what will be the rate of departure as you have given here? What will be the rate of departure? So from 1 to 2, from 2 to 1, unit 2 fails. So what is the failure rate for unit 2? For those who have drawn in the last class, you might have written the arrow. What is the failure rate for generation 1? Lambda 1 is the generation 1 failure rate. Mu 1 is the repair rate for unit 1. So that means from state 2 for going to state 1, you are actually repairing. Okay. That means mu 1, right? Mu 1. That means 2 to 1. The rate of departure is mu 1 because you are repairing unit 1. What is the other one? 2 to 5. What should be the rate? Departure rate? Unit 1 is 2 to 5. 2 to 5. Unit 1 is down. No departure. Unit 2 goes from up to down. Okay. Lambda 2. Right? So this should be lambda 2. Right? Got it? For unit 3, for the transition from 2 to 6, unit 3 is down. So what is the rate? Departure rate? Lambda 3. Because lambda 3, right? Unit 3. Okay. For unit 1, failure rate and repair rates are lambda 1 mu 1. For unit 2, the failure rate and repair rates are lambda 2 mu 2. For unit 3, the failure rates are lambda 3 and mu 3. So when I say transition from state 2, okay, so when I say transition from state 2, what is the total departure rate? Mu 1 plus lambda 2 plus lambda 3. So how much is that? How much is that? In the previous slide is there the failure rate. What is the failure rate? And repair rate. The question. So write down this mu 1 lambda 2 lambda 3. Okay. So we go there. So we have got. So from state 2, the transition was how much? mu 1 plus lambda 2 plus lambda 3, right? Okay. What is mu 1? Mu is same for all units. 0.49 and lambda is 0.01. So departure rate is 0.49 plus 0.1 plus 0.1. So that is equal to 0.5. If the departure rate from state 2 is 0.51. Is it clear how to calculate the departure rate? Clear? So to check your understanding. So I will show you this. So we just calculated for unit for the state 2. Okay. For the state 2 it was 0.49 plus 0.01 plus 0.01. So that is equal to total is 0.51. Right. So for your job make this table. Write down states. So don't see the answers to compute yourself. Here you write states. States. Okay. So in the states 1, 2, 3, 4, 5, 6, 7, 8, and that you are drawn in your diagram. All the 8 states you have drawn in your diagram. I'll show you the diagram again so that you can see the all the 8 states. So in the state 2, unit 1 was in the state 2, unit 1 was in the state 2, unit
down. Unit 1 was down.
Unit 1 was down. So what was the, from state 2? What are the transitions that you are making from state 2 to 1? Then
2 to 5.
5, and then
2 to 6.
2 to 6. So if you make these 3 transitions, total departure rate becomes 0.51. Your job is to now find out this departure rate for all the states. Okay, all the 8 states. Okay. And consider only single state transition. Those who have drawn the diagram, they have made the arrow for single state transition. So compute. This answer is given, but you compute yourself.